This is lesson 3-5 about linear intervals, and it starts in your workbook on page 196. This is example 1 on page 196. It says, an express train reaches its travel speed of 150 miles per hour a short time after leaving the station, and travels at this speed for an extended period of time. What does a qualitative graph of the distance the train travels over time look like once it reaches its travel speed? All right, so this is still example 1, and the first thing we need to know is what is a qualitative graph? Well, a qualitative graph represents the relationship between quantities when you don't use numbers. You just talk about intervals and what's happening in the intervals. So in our graph, we have the time the train is going and the distance it's going. And if you notice, it said up in our prompt that it reaches its travel speed of 150 miles per hour a short time after leaving the station. So right here, I'm guessing that's when the train is getting up to speed. So you're going to notice the train starts at 0, and it takes it a little time for it to get up to speed. But once it's up to speed, it's going to go at a constant rate. You're going to notice that we have a vocabulary word here, and that's the word interval. And it simply means that this is a period of time between two events. So our first interval is from the beginning of the train to when it gets to its speed. And the second interval is the constant rate of speed. So when you're drawing a qualitative graph, I want you to pay attention to what is happening. If we are talking about time and how far the train is going, it takes a little bit of time to get up to speed, and then make sure it's a nice straight line showing that it is a constant rate. This is going to be an increasing interval. Actually, both of these are increasing intervals because they're both going up. In other words, as time is increasing, so is the distance. But generally, we think about an increasing interval looking like this. All right, we're going to try this on the bottom of page 196. It says the graph at the right shows another interval in the train's travel. Which best describes the behavior of the train in the interval shown? The very first thing I want you paying attention to are your labels. Although we still have time here, we have changed the label on the side. It's no longer distance, it's now speed. Now this train is not stopped. It has some speed, but the speed is decreasing as time is increasing until the train has no speed or it is stopped. So as time increases, the speed of the train decreases. And so this is a decreasing function. And you're going to notice a decreasing function generally looks like that. In a decreasing function, one variable is going up while the other is coming down. This is example 2 at the top of page 197. It says the graph shows the behavior of a ball that a soccer player kicks to a teammate. Describe how the height of the ball and the time are related in each interval. Remember, we're going to really cue in on these labels. So we want the height of the ball versus the time. So first we're going to determine whether the function is increasing, decreasing, or constant during each interval. if you look at this first one, as time is going up, let me get a different pen for this. As time is increasing, so is the height of the ball. So they are calling this first interval as an increasing interval. Then the ball, at some point in interval 2, decides gravity is not its friend, and it starts to go this direction. As time is increasing, height is decreasing, and so that is a decreasing interval. We are on the try it, kind of in the middle of page 197. And it says the graph shows the behavior of Skyla skateboarding at a skateboard park. In which intervals is the function increasing? When is it decreasing? And when is it constant? All right, I'm going to have you stop me here. Make sure that you are talking about which intervals, whoops, well, let me try that again. Which intervals are increasing? Which intervals are decreasing? And which intervals are constant? Just a short reminder, increasing means both variables are going up, and it usually looks like this. Decreasing means one variable is increasing while the other is decreasing, and it usually looks like that. And constant just means everything is stable, and it usually looks like that. So go ahead and pause me here while you decide which intervals belong where. Come back for checking when you're ready. All right, let's go ahead and check your answers. Interval number 1 is going this way, that is decreasing. 2 seems pretty stable down here. We're going to call that constant. 3 is going back up, that's increasing. And 4 is going down again, that is decreasing. Those are your answers. This is example 3 on page 197. In which intervals is the function increasing, decreasing, or constant? All right, so one more time. If something is increasing, it means both variables are going up, and it usually looks like that. So we are going to say that this one is increasing, this one is increasing. If a function is decreasing, that means one variable is going up while the other is coming down, and it looks like that. 5 is decreasing. And then finally, if a function is constant, it remains like this. 2 and 4 are constant. All right, so now that you know about intervals and you understand the idea of increasing and decreasing and constant intervals, what could this graph represent in real life? When would you have time versus distance, and you would start at 0 distance, you would go up some distance and then hold right there. And then you'd go up some more distance and hold right there. And then you'd go all the way back down to no distance. When could that happen? So I'll give you one of my ideas, and then I'm interested if you'll tell me your ideas next time I see you. I think about a water slide. So it's been a long time ago, but there used to be a water park called Wacky Waters, and it had this fabulous water slide. And you'd climb up, and then you'd have to wait because there were so many people going. And then you climb up a little further, and then you had to wait. And then when it was your turn, you went down the slide, and you ended up back down on the ground. That's not the only thing this could represent. I'm interested. Tell me next time you see me, what did you think this graph could represent? This is your key concept. on page 198. You can describe the relationship between two quantities by analyzing the behavior of the function, relating the quantities in different intervals on the graph. So intervals, if you remember, are just in between two events. Sometimes intervals are increasing. This is increasing. Sometimes intervals are constant. They're not doing anything. That one is constant. This one is constant. And sometimes they are decreasing.